Okay, so hi, I'm Tomasz Żyjewski, and this presentation will be about pros and cons of various layer management tools. So here is an agenda of this presentation. First, I will introduce myself and the company I work in. Then we will briefly talk about Yocto layered model as part of refreshing a few basics. Next, I will point out the goals of this presentation. Then I will describe the project I used to test the mentioned layer management tools. And after every one of them will be discussed, I will finish my presentation with a quick summary. So once again, my name is Tomasz Żyjewski, and I'm an embedded systems engineer at FreeMDep. I have been with FreeMDep only for over a year, during which I gained experience related to Yocto. Other than Yocto, I'm mostly interested in Golang language, and if you would like to contact me, you can use email listed here on slide. Okay, so I would like to share a few words about FreeMDep. Our company is an embedded system consulting company. We are based in Gdańsk, which is a city in Poland. And one of our main goals is to promote open source solutions by using them on firmware and systems we work on. Okay, so let's make some introduction to the problem and recall some basics. Assume we are starting a new project and we need to prepare a system for a new platform. The beginning of the work with the Yocto project can be described as follows. So first we need to prepare a description of requirements which our embedded system has to fulfill. Then we transform these descriptions into a list of tools and packages we want to install in our image. And as we know, in case of Yocto, every package is delivered by a corresponding recipe. So at this moment, we can decide to provide all required recipes from our main repository, or to search, for example, using the layer index, and to reuse the work that was already done. When we decide to use layer index, we'll discover that there are many layers already existing that provide a large amount of metadata. Okay, so what are the layers in the Yocto project? One of the many features of the Yocto project is the fact that it uses a layered model, which means that it groups related functionalities into separate bundles. These packages can be added to the project at any time, keeping in mind that some of them may depend on other layers. Layers breakdown that isolates and groups functionality also reduces the complexity and redundancy of a design. All this allows you to easily expand, customize, and organize projects on which you are working. The layers are usually repositories, yes, so they're containing metadata like recipes or configuration files that are telling open embedded build system what to do. Layers can and should be used to logically break down information about our build. For example, we divide the layers into those providing BSP, GUI, or applications. Keeping all the metadata in one layer is of course possible, but it has a negative effect on the future reuse and improvement of a given layer. So the main idea to follow when creating layers should be that the layer structure is as modular as possible. As already mentioned, a properly prepared layer should contain the smallest set of metadata so that it can be used as freely as possible in several projects. So this means that even the simplest projects can consist of several layers, 6, 7, 8, where, as we know, each of these layers is a separate repository that is still being developed, which means that we need a specific version of this repo, and we also want to slightly modify this repo to our needs sometimes. Okay, so we can easily imagine that more complex projects will contain more and more layers. So let's say 15, 20, and maybe 30. Now imagine a person who starts working on such a project, and the first information he receives is that he has to prepare more than 20 repositories, and only then he can start working properly on the image being built. Fortunately, the Yocto layered model also allows to prepare user-friendly tools for managing layers. Some of them allow you to prepare the appropriate repositories needed in the project, like clone the repositories and make the checkouts to the correct revisions. And others go deeper into the open embedded build system, allow you to modify the configuration files like bblayers.conf and localconf. In my presentation, I would like to present 4 such tools, and they will be use of Git submodules, use of the Google repo tool, a combo layer script which is available from the POC repository, and last but not least, cast tool available from the Siemens repository. The main goal of the presentation will be to present the advantages and disadvantages of each of the above mentioned tools so that everyone can independently evaluate and choose the one that best fits their preference or project requirements. Choosing one of them is one of the things you should do when building images with the Yocto project. It is also worth making this choice at the very beginning of your adventures with the Yocto project and then getting to know it inside out. A good developer knows various tools and is able to use them, but a very good developer should choose the ones that suit him best and gets to know everything about it. So now let's talk about the project I will use to show these tools. So it's best to learn new things, seeing how they work in practice. So I'll use the 4 tools mentioned in one project. This project is large enough to show the possibilities of the tested solutions. In the project, I will use Raspberry Pi Zero, on which I will run X11 server, allowing to use the Chrome browser. Due to its low price and good Yocto support, the Raspberry Pi is a good hardware for learning and getting to know the Yocto. We will make some changes also in the build configuration files to set custom distro, machine, and some variables. Okay, so in the project, I use the following layers. It is the Meta, Open Embedded, and POC, which are the basic layers used in builds. Each of them contains smaller layers, and we will use some of them, like, for example, Meta Networking. Next will be the Meta SVU update, because the part of the build can be an SVU file which can be used to update the system. Next is Meta WebKit, which provides some useful tools, including benchmark tests for browsers. Another one is Meta Raspberry Pi, is a Raspberry Pi layer, which provides, among others, machine configuration files for used hardware. And last will be our custom layer, which I named Meta Presentation. And we will use that layer to store every configuration file or other BB appends, which will be added to the recipes we use. And finally, we want to patch one of the existing layers to modify the script to our needs. So to make a quick presentation goal summary, as I mentioned, the purpose of this presentation is to show 4 tools to layer management. So I will prepare described project 4 times. The purpose of such task will be to compare how the tested tools cope in such a project. The listed project requirements cover most of the tasks that we would have to face when preparing the layers and the entire build to work. The order of the checked tools is random, and each tested tool will end with a table showing the pros and cons of a given tool. I assume that all custom operations should be performed from the meta presentation layer, which I was mentioned before. Okay, so let's start with the first layer management tool, which is the Git submodules. The Git submodules are one of the Git's internal tools. Obviously, its use depends on installing the Git. By checking its description at the gitscm.com, you can find the following information, which I posted here on the slide. The other words, it says that sometimes we have projects in which we want to use some other smallest project, and this smallest project we can compare to the layers used in the Yocto. So I think that because its description perfectly match the layers used in Yocto, because layers should be separated, and it should be easy to use more than one layer at a time. Okay, so how it works to use Git submodules with the Yocto layers. So adding new layers is done by calling the command git submodule with the URL. So for example, if we want to add the POCI, we just type inside our custom meta layer repository git submodule add and the source of the and the URL site address to the POCI repository. And after adding every needed submodule, we need to commit changes. So for example, we can git commit with a message that says is add needed meta layers as submodules. And we will see the list of the layers which are added to our meta layer. Please notice the mode for layers entry, it's 16.0000. And this is a special mode in Git that basically means you are recording a commit as a directory entry rather than a subdirectory or a file. Okay, next. By moving, okay, so after we add layers to our custom meta layer and we check on where they are checked out, we can see that they are checked out on the top commit from master branch. And to set the appropriate revision, enter a given layer and set the revision, then exit that layer and commit the changes. So for the POCI, it will be cd to the POCI directory, then git checkout to our specific revision, then cd out from that directory, add changes, and run git commit. As we can see on the difference from that commit, it shows that only respec on the respec, so revision of the given sub project has changed. So from now on, when we will init and upload our submodules, they will be checked. They will be checked to our revision. So in this case, it will be a revision which starts on 8.8c6. Okay, the next step is to apply the patch to a specific layer. In our custom layer, we have a patch that we would like to apply to the POCI. We will do this as follows. So copy the patch to the POCI repository, then git apply, and with git status, we can see that the files are modified. Unfortunately, applying such a patch must be done manually during each download of the submodule from the POCI, and the only automation will be adding an additional script that will download the submodules and patch the appropriate layers. Okay, so the last thing we want to tweak before running the build is to set the configuration files inside the build directory. So VB layers and local configuration files. And of course, we first need to manually prepare the bitbake environment using the OA init build script. Unfortunately, also this time, the use of Git submodules does not allow us to interfere in real time with the configuration files used in Yocto. Such files must be kept somewhere else, for example, in our custom meta layer. Then we can just copy it after we run our init build environment, or just run our init build environment with a special variable, which is template conf. However, it should be remembered that each additional command required to be entered by the developer means another possibility of an error. So a quick summary of the Git submodules. It does not require additional dependencies because most developers already use Git, and it is easy to use. From the conside, we have a limited Git submodules is limited to downloading selected layers and the revision settings. and the preparation of the environment requires manual work or something related to writing scripts. For this reason, it may cause some errors. Okay, so the next tool will be repo. Repo is a tool built on Git. It comes from an Android open source project where we also deal with the management of a large number of repositories. Its task is not to replace the Git, but to facilitate work with it. And the repo command itself is a Python script that can be run from anywhere when added to the path. So to use repo as a layer management tool, we need to download it to somewhere when path variable sees it. In my case, it was the home and bin directory. And then when you need to make it executable, and after type repo help, we see the help message of the repo command, which does, for example, that init command will install repo in the current working directory. Okay, so repo works with manifest files. In the case of Yocto, the file will contain the list of layers with the appropriate revisions. To our custom layer, default.xml manifest file was added with the following content. So we see that every meta layer has its entry, and the meta layer here is named as the project. So we have the name of the project, the variable remote, which points to the source from where we will be fetching our layer. And we also can set, for example, revision, which we will want to use. It is worth noting that the use of the SSH may be needed when downloading private repositories. Okay, so to initialize the build using the repo, we should create a new folder and then run the command repo init from it with proper URL. So in our case, it'd be, for example, create an Yocto Project folder, cd into it, and then type repo init -o, and then add the URL of, for example, our custom meta layer with default XML file, where we can also specify the branch adding -b flag. After successful initialization, we execute the repo sync command to get all the layers. They will be checked out to the revision set in manifest file. Unfortunately, when it comes to preparing layers, this is all we can achieve, and custom patch that we are going to apply to the POKey, also this time it has to be added manually or by script. Repo as a tool also does not strictly affect the preparation of the environment for Yocto. This time we also need to previously prepared configuration files and take care to prepare the environment by using OA init build environment, and then copying local conf and bb layers conf file or use the template conf variable. As with Git submodules, this step must be repeated every time you start working on a project. Moreover, future changes will also have to be changed manually. So, as we know, it may cause some errors. Okay, so let's go to the summary of the repo. It has many built-in options that allow you to control what you want to download, set the revision, use some given branch, etc. Is based on a manifest file downloaded from anywhere, so it can be our custom meta layer, which briefly and accurately describes the elements, in this case layers, included in the project. And it is a popular solution, it is often used solution, which means that it is also a well-tested solution. From the cons side, we can say that it requires some preparation before use, for example, installing a script into the path. And as with Git submodules, modifying anything other than the list of layers in the appropriate revision is impossible, and it requires writing additional scripts. Okay, so let's look at the next layer management tool. Combo layer is a command line utility for creating and maintaining Git repositories that are a combination of several other Git repositories. The script combo layer can be found in Pocket. So if we will go into the Pocket directory and then script directory and run the combo layer with -h flag, it will print the help of the combo layer, and as we can see, we can make some actions like init and update with the combo layer, which we will be using later with our project. They should initialize the combo layer repo and get patches from the component given in the configuration file. Okay, so if we want to put all the necessary files in our own layer, we can copy the script to it and prepare an appropriate configuration file there. For each layer, it looks like, the entry looks like this. So we have the name of the layer, like MetaWebKit. Then we have some variables which are mandatory and others are optional. From the mandatory variables, we have the source array, which points to the sources from which we will be fetching our meta layer. Then we have local repo dir, is the path to the directory when the layer will be cloned. And then we have the last revision, which points to the revision we want to use. From the optional variables, we have, for example, file exclude variable. Then if we give there some path to the we can give the path to the directory from which we don't want to use any files. Okay, so to prepare our mega layer, as I can say, as I can name it, we can create empty directory, clone inside our custom layer, and then run combo layer init action with the configuration files stored in our custom meta layer. When using combo layer, we do not so much prepare the layers to be built, but create a new combo layer as a repository, which we can then command and track the history of all layers inside as one. Compared to the previous tools, it is such a powerful tool which, for example, through file exclude allows you to choose which of the files you ultimately want to include in our combo layer. Unfortunately, if we want to patch the selected layers in the next step, we still have to do it manually. No automatic option to apply local patches. And combo layer, similar to the previous tools, also is limited to preparing appropriate layers and metadata files. Using this tool, we are still forced to manually configure localconf and bblayersconf, as well as prepare the environment for build. So summary for a combo layer. From the PROS side, we can say that it uses transparent configuration file for selected layers and their contents. It is powerful in case of customizing used layers, and if self-contained, it is a self-contained repository. And from the con side, we can also say that it is a self-contained repository, but because not always we want to have that big repository which contains every layers we use in our project. And because of that, reviews might be time consuming if there are many changes in many layers. Okay, so let's go to the last layer management tool, which is the CAS. As we can read from the repository README, CAS provides an easy mechanism to set up Bitbake-based project. CAS allow us to done the following steps. So we can clone and check out layers, we can create default settings, we can launch minimal build environment inside Docker container, and initiate Bitbake build process. The easiest way to use CAS is to download script to CAS Docker, with which all builds will be done in the container Docker, in a Docker container. Unfortunately, it is related to the previous Docker installation. So we can then download the script to the path and set it as executable. When we run CAS Docker script, we see that there is a bunch of arguments we can use. For example, if we use the build argument and the builds for given in the class configuration file target will start, and we can, for example, also use shell argument, which run a shell in the build environment. Okay, so we run the CAS Docker script with the CAS configuration file that defines how we want to prepare the build environment. First, let me show you how to prepare an entry for a given layer. For example, for Meta Raspberry Pi, it would be just Meta Raspberry Pi as the name of the layer, then the URL which points to the repository we want to clone, and then we can give the ref spec, which is a revision we want to use. In case of CAS Docker, it is best to store CAS files in the custom layer, and when we start work on the project, we just create a new directory. Let's call it, for example, Yocto Project. Then we clone our custom layer, and from the Yocto project, we call the CAS Docker script as shown on the slide. So it is the CAS Docker build meta presentation / CAS YAML. After calling the CAS Docker command from the Yocto project, all layers described in the configuration file will be cloned and checked out inside our Yocto project directory. Okay, so in addition, when CAS Docker script is called, CAS also allows for custom modification of configuration files, like BBLAs and local configuration files, at the time of launch, because we also get an environment prepared for build, like in case of running source or init build environment. To set matching and distro, we need just to use variables inside the CAS configuration files, which are named distro and machines. The BB layers variable in the BB layers configuration file will be automatically generated based on the entries from the CAS configuration file. And for this build, it looks as follows. When we see, for example, path to the meta open embedded, path to the meta open embedded and meta multimedia, the meta networking. In this case, the repo points to the layer from which we run our CAS configuration file. So this time it will be meta presentation. Okay. When it comes to local configuration files, returning to the BBLAS configuration files, the beginning of this file can be defined inside CAS configuration file by variable BBLAS conf header. So if we set in BBLAS conf header things like BB files and BB path, it will be copied into build.conf BBLAS conf file. The same case is when it comes to the local conf file, but this time it will be the variable named local conf header. So if under local conf header in CAS configuration file, we will set, for example, extra image features. After run it, it will be copied into the build.conf local conf file. So CAS also allows you to patch cloned layers when you run the script. In CAS file, it should be described as follows. So this time we assume that the patch will be stored in the meta presentation patches and name of the patch, and it will be applied to the POCI while everything is initialized. So let's make a summary of the CAS as a layer management tool. It allows a large customization of the build environment, no need to add tricks and scripts, which simplifies the working stack. Supports bundling the build configuration with a layer, usually the product application. This can noticeably reduce commit clutter. Actually, the only tool that properly prepares local conf and BBLayers conf files, and it prepares build environments, thanks to which, using one command, we can immediately build a recipe using Bitbake. On the conf side, we can say that when using the CAS Docker script, installation of the Docker is required. But of course, we can use the CAS as a Python script, but this container is one of the CAS biggest advantages. So, summary. Each tool is presented with an overview of the pros and cons. I think that such a preliminary description will allow everyone to judge which of the tools suits them best. I encourage you to try each of them and learn about their pros and cons for yourself. Remember that these are only tools, and you need to know them well to be able to evaluate them yourself. In my personal opinion, the best tool is a CAS tool because using it, I can prepare not only the layers but the whole build environment. Okay, so thank you for listening to the presentation, and if there are any questions, I will try to answer them.